Here's a function, f of x equals absolute value of x. Let's figure out where this function is and is not differentiable. So I'm going to set up the difference quotient. My limit that I'm taking is the limit of h going to 0, and I'm taking the absolute value of x plus h, all minus the absolute value of x, and that whole mess is divided by h. Now, it'll be easier to work with this quantity if I know that x is positive. So if x is positive, then I know that the absolute value of x is just equal to x. And since h is going to 0 anyway, we can say that h is small enough where x plus h is also positive, which means the absolute value of x plus h is also just x plus h. So that'll clean up the algebra very nicely. So this limit simplifies down to the limit of h divided by h as h goes to 0. And we should be able to see that that is just going to be the limit as h goes to 0 of the function 1. So this is just 1. So this limit exists, this derivative exists, so long as x is a positive number. Okay, cool. Let's see if we can get this derivative for negative numbers. So if x is a negative number, I have to use a different formula for the absolute value function. My absolute value of a negative number just says put an extra negative sign out in front. So absolute value of x is minus x. That's okay, I'm getting my double negative there to bring me back to positive. And again, I'll pick my h so small that x plus h is still a negative number. And I can do the same trick with my absolute value of x plus h. Now, my limit, again, I'm taking the limit of quantity x plus h minus x divided by h, right? I'm using that same algebraic trick from before. But this time, when I cancel my x's, that still goes through, I've got a minus sign in front of my h on the numerator. So I'm taking the limit as h goes to 0 of negative h on h. Well, that's just going to be minus 1 when I take the limit. So this derivative exists. It's equal to minus 1 for any negative value of x. Okay, so my function, the absolute value of x, this is differentiable for all positive numbers and all negative numbers. Well, what am I missing? I'm missing 0. Okay, well, let's do 0. So this time, I'm taking my limit specifically at the coordinate x equals 0. So I can go ahead and say I want the limit as h goes to 0. I want f of 0 plus h, all minus f of 0. That whole mess divided by h. All right. So absolute value of 0 is just 0. 0 plus h is just h. This should be the limit as h goes to 0 of the absolute value of h divided by h. Well, that's actually a problem. Because I could have h to the left of 0, right? I could have negative values of h, or I could have h to the right of 0. And depending on which of those two places we're coming from, we will get different values for this limit. So coming in from the right, my limit will be +1. Coming in from the left, my limit will be -1. But that means that the two-sided limit does not exist. This limit at the top of my slide does not exist. So f prime 0 does not exist. All of this is saying that the function f of x equals the absolute value of x is not differentiable at 0. It's differentiable for every other value of x, right? Positive or negative, but it is not differentiable at 0. So the derivative that I get is actually this picture right here in pink. F prime of x is a piecewise function. It is +1 for positive values of x. It is -1 for negative values of x, and it is actually undefined for x equals 0.